Jordan, Anna and Ryan collect picture cards. Cards are worth either 50 points or 100 points. This table shows the cards they have. Complete the table for Anna and Ryan. So to see how this table works, let's look at the row that's been done for us. Jordan has 5 cards worth 50 points, so that's 250 points altogether. He has 2 cards worth 100 points, so that's 200 points, and then we can see that the total number of points is 450 because 250 plus 200 is 450. So now let's complete the table for Anna. She has 3 cards worth 50 points, and 3 times 50 is 150. We don't know how many 100-point cards she has, but we do know that she has 550 points altogether. Well, 150 plus 400 is 550, and if cards are worth 100 points each, she must have 4 of these cards, because 4 times 100 is 400. Now let's look at Ryan. He has 4 cards worth 50 points, and 4 lots of 50 is 200. Then he has 6 cards worth 100 points, so that's 600 points altogether. So to find the total number of points, we need 200 plus 600, so that's 800 points altogether. Shade 2 squares and 1 triangle to make this design symmetrical about the mirror line. Remember, if something's symmetrical, then we have the same on both sides, so we have the same shapes facing each other. So this square here and this square here are symmetrical, but now we need to shade 2 more squares and 1 triangle. So we need to shade this square here so that it's opposite to this square, and then if we go up, we have this square connecting the squares shaded, so we need to shade this square as well, and then we have our triangle here, so on the opposite side we need a triangle here. Now this can be tricky, but it's much easier if you turn your paper around, so rather than a diagonal mirror line, you have a vertical mirror line. That way it's much easier to spot that this square here is opposite to this square here, and this square opposite to this square, then this triangle opposite to this triangle. So it's a good idea if you have a diagonal mirror line to turn your piece of paper around, and then you can see what you need to shade. Here is a shape on a square grid. For each of the 4 sentences below, put a tick if it is true, put a cross if it is not true. First, angle C is an obtuse angle. Well, if we look at angle C, we can remember that an obtuse angle is larger than a right angle. So remember, a right angle is like the corner of a piece of paper or the corner of this screen. So because angle C is larger than that, we know that it is an obtuse angle. Now, angle D is an acute angle. So let's look at angle D. It's in fact not an acute angle because it's a right angle. We know that it's a right angle because we can go across one and up one to get to the line, or across one and down one to get to the line. So because we're going across and up or down by the same amount in both directions, we know that angle D must be a right angle. Next we have line AD is parallel to line BC. What they mean by line AD is the line connecting points A and D, and BC is the line connecting points B and C. Now remember, parallel lines are like train tracks. They would go on forever in both directions without ever crossing. But we can see that these lines here are not parallel. If we extended these lines, they would cross at a point, so we know that they're not parallel lines. Finally, we have line AB is perpendicular to line AD. So perpendicular is like the opposite to parallel. Perpendicular lines will cross at right angles if they're extended. So we need to look at line AB and line AD. We can see that angle A is a right angle because again we could go down and across one or down and across one. So going down and across by the same amount each time takes you to the line. So because perpendicular lines make a right angle and angle A is a right angle, we know that these lines are perpendicular. Join the dots to make a pentagon with only one right angle. So we need to remember that a pentagon is a 5-sided shape and a right angle is a 90-degree angle. So that's the size of a corner of a piece of paper or the corner of this screen. So to make a pentagon with only one right angle, I think it's easier if we make our right angle first, and then because a pentagon has 5 sides, we need 3 more lines. So if we draw 1, 2, 3 more lines, then we've made a pentagon with one right angle. But there are lots of possible ways of doing this, so lots of possible answers. Now join the dots to make a pentagon with exactly 2 right angles. So again, we can make our right angles first. So if we draw 3 lines like this, we've made 2 right angles, one here and one here. So now we need 2 more lines, and then we have a pentagon with exactly 2 right angles. In the circle, write plus, minus, times or divide to make the calculation correct. So we have 18 and either plus, minus, times or divided by 3 times 5 equals 30. So 18 times 3 would give us far too many, so let's try 18 divided by 3. 18 divided by 3 is 6, and then 6 times 5 is 30, so our missing operation is divide. It's also important to understand that if we had plus or minus here, we would have to do 3 times 5 first, because with the order of operations, we always divide or multiply before we add or subtract. Circle the numbers that are multiples of 7. So remember, a multiple of 7 is a number in the 7 times table, or a number that can be divided by 7 without leaving a remainder. So 27 is not a multiple of 7 because it's not in the 7 times table. 27 divided by 7 is 3 remainder 6. But 42 is a multiple of 7 because 6 times 7 is 42, or 42 divided by 7 is 6. 52 is not in the 7 times table. 52 divided by 7 is 7 remainder 3. 63 is a multiple of 7 because 9 times 7 is 63. And 77 is a multiple of 7 as well because 11 times 7 is 77. Now this question was fairly easy because all the numbers that we're given are in the 7 times table up to 12 times 7. But if you're given a larger number, to decide whether it's a multiple of a number, so a multiple of 7, you could try dividing it by 7 and then remember, if you get a remainder, it's not a multiple. Emma uses 5 shapes to balance a 50-gram weight on a scale. Each square weighs 12 grams. How much does each circle weigh? So we know that each square is 12 grams, so I find it useful to write 12 on the squares. So then we can see that altogether 3 times 12 is 36, so 36 grams is the weight of the squares. So 36 grams plus the 2 circles must equal 50 grams. So we can work out what the 2 circles weigh together, because 50 minus 36 is 14. So 2 circles must weigh 14 grams, because 36 plus 14 is 50. But we want to know the weight of one circle. So if two circles weigh 14, we can find the weight of one circle by dividing by 2. 14 divided by 2 is 7, so each circle must weigh 7 grams. 12 plus 12 plus 12 plus 7 plus 7 is 50, so we have our answer. Sapna makes a fruit salad using bananas, oranges and apples. For every one banana, she uses 2 oranges and 3 apples. Sapna uses 24 fruits. How many oranges does she use? So what we have here is a ratio question, and usually we can solve ratio questions by using bar models. But here, because the numbers are small, we can just draw out what Sapna has. We know that for every one banana, she uses 2 oranges and 3 apples. So we have B for banana, 2 O's for 2 oranges, and 3 A's for 3 apples. So that's 6 fruits altogether, but she uses 24 fruits. Now 24 is 6 times 4. So if we take our 2 oranges and multiply by 4, we get 8 oranges. We can see that if we make 24 fruits, we have 8 oranges, so she uses 8 oranges. Liam thinks of a number. He divides it by 9 and then adds 25 to the result. His answer is 36. What number did Liam start with? So he thought of a number, divided it by 9, then added 25. His answer was 36, so this question becomes a lot clearer if we draw something like this. And you don't need to waste time drawing boxes, but I find it really useful to draw arrows and then what's happened in order. Then, to solve this question, we really just need to solve missing number problems. So we work from back to front, so we have something plus 25 is 36. Well, 36 minus 25 is 11, so 11 goes in this box here. And then we have something divided by 9 is 11, so to work that out, we need to multiply 11 by 9, and that gives us 99. So Liam started with 99. Remember, when we're working backwards, we use the inverse. So because it's add, we subtract. Because it's divide, we multiply. Seb bought 2 apples and 3 pears. He spent £1.59 altogether. Apples cost 24 pence each. How much does 1 pear cost? So we could use bar models to solve this problem, or we could try without. So we know that apples are 24p, and he bought 2 apples. So if we multiply 24 pence by 2, we get 48 pence. So that's how much he spent on apples. But we need to know the cost of 1 pear. First of all, we can find out how much he spent on 3 pears, because we know that 48p of the £1.59 was not spent on pears, it was spent on apples. So we can work out £1.59 minus 48 pence. That gives us £1.11. So that's how much he spent on 3 pears. But we need to know the cost of 1 pear. Now, if we know how much 3 of something cost, we can find the cost of 1 of that thing by dividing by 3. So we need to divide £1.11 by 3. We can do that using short division, and you might have wanted to use column multiplication or column subtraction to work out these up here. If we do that, we copy up our decimal point, 1 divided by 3, 0 remainder 1, 11 divided by 3 is 3 remainder 2, and 21 divided by 3 is 7. So he spent 37p on 1 pear.